Is my screen visible? Yes. Okay. So, so basically, the topic which I was asked to speak on is generative AI. See, given that there are millions of resources on generative AI across YouTube, I thought I'll try to be a bit more uh, pessimistic, for the lack of a better word, and see if we can just see beyond the hype. Basically, temper expectations or maybe increase expectations, try to figure out what exactly is happening just by asking different questions, and maybe some are true, some are false. So the whole idea here is to have a debate, basically, on various aspects of generative AI and how it affects us. So the idea is I start with a question, maybe provide two sides of the argument. I mean, there is at least one question which doesn't have any side as such. It's a general short discussion which we want to have. And basically, I want everyone to pitch in where you lie and why is it so. Please feel free. Like I might sometimes do make controversial statements or statements which are wrong or could be proved wrong in the future. So, because this is still the edge of science. Um, so the key aim is the attitude which I expect is basically as long as we are discussing and debating stuff, I think it should be okay. But please do try to be respectful and civil to others' opinion. So let's start with a joke because that's how it can be interesting. So see, the one of the basic things is that we all take logic and rationality as a given. Unfortunately, that's not even close to being true. So there is one of my favorite books called Thinking Fast and Slow, which talks about human biases. And then there is a book called Influence by Caldini, who also talks how salespeople use our own biases against us to sell us things which we don't really need or sell us it at a cost. So the following joke is, I think, I've taken from someplace, I forgot which, but he sort of tells you which is it. So one of the uh, friend one says that, I can bet you that if I flip the buttered toast, it will always fall on the buttered side. Friend two says, okay, I will take that bet, and it won't. So the friend two takes the side and flips it in the air, and it falls on the non-buttered side. So the friend one says, you must have buttered the wrong side. So the joke here is actually easy to see. Basically, the friend one is acting under the assumption that he's always right. It's the nature which is wrong. And sometimes logic and rationality can be a tricky thing. Like you can get stuck in logic so much that you feel that nature is wrong, but what you did is right. So it's very, very important to distinguish these two. So, for instance, recently I was hearing to some podcast and I heard a statement like, "Oh, no matter what you want, there exists a prompt in ChatGPT such that which will give you the answer." I mean, there is a lot of um, bad. I mean, it might even be true. I don't even know if it is true, but even if it is true, it might be saying as much as saying that, okay, it's just that your answer is wrong. I mean, what if ChatGPT says your answer is wrong instead of saying that? So, so basically, you have to understand that these aspects are actually playing a huge role. So, our own biases and our own lack of rationality or too much of it can actually be a problem. So, let me start with. So, this will be the first question which I want to start with. Say someone, I mean, I'm not talking about LLMs here. Say I give you a black box. But then what it does is, if you actually know the answer, it gives you the answer. And if you actually don't know the answer, it will give you either the right answer or the wrong answer. For simplicity, assume there are only two things, not something in between. So the question is, how do you evaluate such a chatbot? Would you consider it completely useless? Or would you consider it, you know, maybe, even if you know the answer, like it will give you the answer. So maybe you can use it to automate some stuff because it might be faster than you. So where do you fall? So that's the first question which I put to you.
If anyone wants to give the answer, they can raise it. But I would definitely align with the second one. Like, I think it at least helps automate the answer process.
Okay. So remember that the chatbot which I give, the hypothetical chatbot I gave, knows the user and accordingly does this, which means you can automate maybe your tasks, but not the tasks to another person. You're getting the point?
Yeah. So they must
Yeah.
also know what I know to have the same automation.
Yes. Right? Yes. Yeah. So it depends entirely on the user. Then where would you?
No, no, no. I don't think that's the point, right? I mean, this black box can only give you the answer. It doesn't give you its thought process or anything. It just gives you the answer.
Yeah.
That's
So yes.
yeah,
Okay. Maybe. I mean, you
yeah,
can also comment on how do you evaluate such a chatbot.
yeah. Um, I think then the evaluation also becomes like how much a user thinks it's useful a bit because I mean the chatbot only knows what the user does. So
Yes. Okay. So yeah, I mean, okay, to be honest, I also don't have a right answer. But so for a long time, I always found, whenever I was interacting with ChatGPT, at least the earlier versions of it, this is what it did. If it gave something which I can verify, then I could trust it and I used it. Most of the times when I couldn't verify it, it's it wasn't really so useful, especially when writing code, at least the earlier versions. I think now it improved slightly thanks to chain of thought and such things, but that's the different agenda. So yeah, the whole aim of trying to have this debate is, as we grow closer to something which is lifelike, something which is which takes into uh, account the behavior of the user itself in its own behavior, then things get murky very quick. Sorry, there was a question.
um so I think Chirag is saying he just posted AGI I guess, but I'm not sure what he
Okay.
means. If you want to unmute and say something. Yeah.
Yeah. It's okay. So basically, the idea is, so what this riddle tells you is it's very, very difficult. It doesn't purposefully lie, but And also the other aspect of AI, which is it entirely depends on the training data, right? What it is trained on. If something is not trained on, then it cannot match the statistical pattern. So, so these things, like, so basically, so this is basically summarizes my entire point that as as the capabilities increase, and if you actually get to some such thing, it might be very, very difficult as to you know, do it. So you completely like, okay, so I know a couple of you have said it's view two, it's always useful, but I'm actually split. I cannot evaluate this chatbot in any, at least not that I know of. Maybe, I don't know, maybe there is something in the field of zero knowledge proofs or something where it might be used. I don't know. But again, it becomes a lot more murkier and six. So this is the main idea of what I'm trying to say, but let's try to be more technical about it. So people try to trace the current generative AI wave to a lot of things. But for me, however, this article played the pivotal role. So basically, this article, long story short, says that if you increase the compute, if you increase the data size, and if you increase the parameters, then your loss is going to improve. And eventually, if you can get hold of enough data, enough parameters, and enough compute, then you will reach the closest you can to artificial general intelligence. I mean, of course, there are a lot of debates against this too. A lot of people, especially Gary Marcus and the like, start saying it's like trying to reach the moon with building bigger ladders. And then the opposite side says, see, we already can solve a lot of these things. So, so for me, it started with this paper. So let's slightly dive in, like where exactly can, I mean, either of those two arguments be right or wrong? So the first things which came to me was this. Okay, you're counting the dataset size and you're counting parameters. Is it completely irrelevant to anything which is useful? I mean, just because I'm repeating the data a million times does not mean my dataset is any bigger. And more importantly, if my dataset has, say, 1,000 different points all interconnected to each other, having the 1,000 first point, which depends on these 1,000 points, won't make any more information. I mean, doesn't really add any more information than what I really have. So is the x-axis even the right axis to try to have these laws on? The counter argument would be, I mean, who cares? If I'm counting this and I ran the experiment, I got the answer. So which one would you agree with?
I think so. This only concerns the central, like the middle graph, right? The
No, okay, data set. No, parameters also I can actually do the same thing in the sense that like all the MLP in the transformer architecture, there is a permutation invariance there. Like I can permute the in between neurons, and because I'm summing them, it doesn't really matter, right? Let me know if you're not convinced with that statement.
yeah, yeah. I don't think I'm completely fine with the parameter one. I this
Okay,
data
okay,
set one makes sense, but
okay. Okay, okay, okay. This I'm doing it from my laptop. Okay, try to imagine this. So try to imagine the simple MLP. You have an input and you have a huge hidden layer and you have an output.
oh,
Remember
you,
that what,
yeah,
sorry?
yeah, yeah. I go on, go on.
Yeah. So remember now what is happening is the output for each output is basically a summation of weighted averages of the maiden layer, which are in turn the weighted average, which are in turn weights from the inputs, right? Now assume that I actually permute the neurons in the uh, hidden layer. Then would the function change?
Yeah, no.
Right?
It will just
Yeah.
learn something else. Yeah. I mean, like the weights will change basically.
Yes.
Yeah.
So I can actually extend this argument further to say that, I mean, there is already a lot of, you know, permutation invariance built in, and that itself is a lot of information which we lose, right? I mean, saying that, oh, this is the first neuron which comes, this is the second neuron which comes, this is the third neuron which comes, can potentially increase the compute power of these models than taking permutation invariance. So, so counting the number of parameters might actually be useless too. I might have been just like I might have just increased the parameters just so that I'll get trans this permutation invariance. Convinced?
Yeah, I guess somewhat, but I think yeah, not completely.
You can ask me anything. So
Yeah.
basically, what I'm saying is current models have unnecessary invariances built in, which okay, not unnecessary exactly, which may or may not be necessary. The classic example being permutation. And if I remove that, then, and if I say, like, instead of saying that, okay, if I have a hidden neuron, the hidden neuron one will act differently compared to the hidden neuron two, will act differently from the hidden neuron three, would potentially increase the capability of the model. Is that statement, do you agree with that statement? It's okay if you don't agree. I mean, I just want to have a debate here.
Yeah, yeah. Uh,
So just
yeah,
saying
I
that,
don't.
just
Yeah, yeah. I don't
okay.
see how like knowing which neuron. Yeah, the order. I don't think it, like. I mean, exactly what you're saying. I don't think the order does really.
Okay. Let me say this. Okay. So let me give you a different argument why it also holds for the parameters. So early days of deep learning, there was a lot of uh, issue with the neuron learning, like two neurons learning the same thing in the hidden layer. Because of permutation equivariance and the gradient descent, that's entirely possible. Would you agree with that?
Oh, yeah, yeah,
The two hidden neurons might actually learn the same function,
yeah,
right? So that itself has a lot of redundancy inbuilt.
yeah, yeah, yeah.
So
Mm.
if not anything, at least that should give you some sense. I mean, why I am at least arguing that, counting the parameters, increasing the number of parameters won't really increase it. And if you say, okay, I'm not sure how many of you are comfortable with this, but if you say add, 100 residual blocks at the end, all you might be doing is learning an identity function,
Right,
which
right.
is
Oh, yeah, yeah, yeah. Makes sense. Yeah, I think I get what you're
which
saying.
is entirely useless. So it's also depends. I mean, see, they did it very optimally, but again, I'm not saying they are right or wrong. What I want to say is the access even right?
Mm-hmm.
And I can actually say the same thing for compute too. I mean, the way they compute this floating point operation. So yeah, so where do you stand on this?
I'm just thinking what view one implies. Like if the axis is wrong, suppose, and
Yes.
and we still see a trend going down on the wrong axis, then so basically what you're saying is we don't know how it performs on the right axis, right?
Yeah. I mean, basically, whenever you're plotting, even the axis, whatever you're measuring itself is wrong.
Yeah.
That's view one. But view two is basically, the counter argument. I don't care. I did this. I'm getting a line, so it should be true. Okay, but okay. So in the broader point, would you at least agree with me that things are getting a lot more murkier now that we are diving deep into it?
Yeah. I think that's yeah.
Yeah, so that's the main driving point. Because to be honest, even I don't know the right answer here. I mean, I don't think anyone knows.
Yeah.
But things, I mean, the more I think about it, it seems that the less I understand. So I don't know.
So
Okay, sorry.
yeah, go on. Bro.
Yeah, no. I have. I mean, I have a few other questions left. So the other questions which are somewhat related would be, okay, fine. I know that whatever you observed here, you did what was right and you optimized the performance, ignored some data which you probably had, and included some other data which may or may not be true, and you observed it. But at the end of the day, it's just a heuristic. It's exactly like Moore's law, which is again something which we observed. It's not a physical law, and then you will get to physical restrictions at some point of time. So maybe this is not the right way. Who knows?
Um, to go back to that one. So when you say
Yes,
extrapolate, as in like, does it hold indefinitely? Like if we,
yes,
that's the whole point, right?
yes. Yeah. So even if you do increase the data size and increase the parameters and increase the compute,
Yeah. Um,
we don't know.
I mean, the, um, so I don't think it's like unless we have say some form of like a theoretical proof of like say something that derives this exact equation that they've written L equal to D by like whatever constant. Unless then there's like I mean obviously it's just empirical before that, right?
Yeah, I mean, all of this is empirical. They don't, I mean, this is one which this is the best fit line
Yeah, yeah,
to what they observed.
yeah.
And
So
that too, I mean, when I first saw those coefficients, it just felt wrong. 5.4 into 10 to the power 13 to the power 0.95. I mean, if I would have seen those in my, C programming set, I would have probably said that's will give you, some floating point errors. I mean, that's how bad those numbers are.
yeah,
I mean, something to the power very big, whole to the power which is very small. Right? 0.95 and 10 to the power 13.
yeah. So my point was like I don't get the difference between these two um views. If it's like an empirically observed thing, it's just a heuristic, right? What's the so what is the difference between these two
No,
views?
okay. The first few says it's an empirically observed natural law, like
Oh, okay,
gravity.
yeah, yeah, okay, okay. It's a natural.
Like gravity. Second
Right.
one says no, it's a heuristic, it's not a physical law.
Oh, okay, okay. Right, yeah.
Yeah, I guess I don't know which way. Where would you stand on this?
Yeah, like given that access point, I really don't think this. I mean, I don't know if we can say it's a natural law, or I like even before that, I didn't think this was like some natural law, or because this obviously doesn't hold for other tasks, right? I mean, this just I think language modeling. So
This is just language modeling, yes.
yeah, so I don't think there's it's a natural law that if you increase data set parameters on compute, you always get better.
But that's okay. So after okay, but something happened after that in the sense that okay, I think if I remember right, the largest model which they use here is 1.5 billion. I think they increased it to 150 billion and still verified these at a later stage.
Hmm.
It went on, right? And
Okay.
to be honest, that's what we would be interested in. I mean, will the laws really extrapolate is what will tell us where to work on. Like if
Right.
all of this is the only line. So, I mean, the question is very important because that will tell us where to focus on,
Yeah, yeah, yeah. I think
right?
yeah, I get, I understand that. I think there's something like that, like a boundary between what can be computed versus like a similar law for what LLMs can, like what's
Do.
the optimal performance they can get versus.
Yes. So, yeah. So this is just another question which makes it very weird.
Yeah. Also,
Okay.
I guess
So,
I'm like, if anyone else wants to participate, yeah, definitely. I think it's just me and Challa sir. Really. If,
mean, okay, see, if you find these things boring, you can actually ask me anything else you want to. There is no restriction. This is just what I find interesting. So,
Oh yeah, Chirag, go ahead.
Sir, I wanted to ask your view upon the view number two. What about larger models? Do you think they are better?
yeah. So, okay. So again, so what they did was, I mean, so the graph here shows only till 1.5 billion parameters. After this paper was done, they actually increased the size to trillion, I think, if not more than that. Uh, they did get better. But the problem which they faced was the data set, they sort of covered the entire internet and they just don't have any more good data to work with. So that's the bottleneck now.
Okay, so
Uh,
I recently read one paper, and it was about Microsoft's new LLM, which is Phi 2, or we can say P2.
mm.
It is a 2.7 billion parameter model, and currently it's outperforming Google's Nano 2, which is about 30 billion parameter model. What is your stand on that?
Yeah, actually, that is a very good question. So that's exactly what my next thing is. So as you just stated, okay, even if the scaling laws are true, should we focus on, improving, like, no, let's do something which is cost efficient, or would we want to do just larger models? So, okay, I'll start with my view and then I'll get the other person's view. My view is no, better algorithms, I'll take them over any day of the week, over the other any day of the week. So, one of the first things which they teach us in an algorithms class when actually learning complexity, like order and squared, is if you go from order n squared to order n log n, like just the standard sorting, the amount of productivity gains you get, the efficiency gain is unmatched by is unmatched compared to having, say, two times better compute. You can have a order n squared algorithm and two times better compute, but that won't even be close to being enough, and it's also very costly. On the other hand, if you can make it more efficient, like make a order and squared and log n, that itself will give you huge productivity gains. So my view is better algorithms at any day. So in your for your question on what exactly is happening there, I don't know. I mean, the second model you said Llama. That I don't know. Though I haven't actually read that, but I can actually see that why a smaller model can actually work better. All it needs is a better, slightly better architecture, maybe, and also a better learning algorithm, more efficient usage of whatever the network it has. So, for instance, one of the issues, I think this has also been verified in terms of large language models, is most of the parameters are useless. Like you can easily prune 90 to 95%, at least in the standard image models. You can prune 90 to 95% of the parameters without having almost any effect on accuracies. Which by the way, this is called the lottery ticket hypothesis, if you have heard of it. And all that says to me is these architectures are highly inefficient. If 90 to 95% of the parameters are useless, then why don't you start with a smaller model and have a better algorithm to begin with? Why something which is cost effective, which is, you don't really need millions of dollars in venture capital funds. So that's my view all along. But then there are a lot of so yeah. What do you think? That do you think it's silly to have better algorithms, or do you think no larger models is the easy like that's where the easiest gains can be made? So we should have larger models. Again, there is no right answer here. So
Yeah, yeah. Um, so Yeah, if anyone wants to say, please raise your hands. But I would like to present that I definitely align with view one as well. I think like um, I mean, I think better algorithms are anyways needed for like if you say move away from any other application other than language. Like there's not really as much data as there is for language. I think to
That's
train.
always true.
Yeah, yeah.
Yes.
And then
So I would like to add something new. There's one more thing, like when we are like feeding data to our LM, basically a model. If we accidentally feed data that has been created by a model, then the like results, the basically the quality of the result, it decreases. So I would like to say like training the model on good and accurate data will be like more effective, because when I read about Phi, they said that they have like created new data curation techniques and the data set that they took was better in general. So maybe that can be also a reason.
Yeah. So I think yes. So basically, what you're saying is synthetic data. Oh, that's a huge debate. I mean, actually, I can actually take an entire hour on that. So the question is, can the model generate data and train on itself to become better? I don't know. That is a slippery slope, in my opinion.
I
Yeah,
would
I don't
hope.
want.
Yeah, I
Sorry,
hope that doesn't happen. Yeah,
I don't think it can happen. I mean,
yeah, yeah.
it's just feels very, very weird if that happens. But then there are people who argued that that would happen.
Um,
I don't know.
but yeah, just to say add something, I've read papers where people say that there's it's called weak supervision and it works out in some cases, but I don't think like the
Hmm.
model generates all that data and then they do it. It's just bad data that's there. Yeah,
Yeah.
probably.
Hmm.
But yeah, I think on this one definitely view one we do need better algorithms.
Algorithms.
Yeah.
But okay. Yeah. Yes. Yeah. So that's also a view I'm sympathetic with, in the sense that sometimes, say, I think it depends on the thing. So, say you are just working with two layers. Having four layers is easy enough. You don't really want to spend time, optimizing it for two layers. I mean, it's still of theoretical interest, but still, you don't want to do that in practice if you're actually building the product. On the other hand, like once you start reaching the limit, I think currently it's they reach that each training run is takes $1 million or something, then it's better to have view one predominates over view two. So yes, so in that sense, I think it's a mixed bag.
I would
Yeah.
also like to say, I think you were commenting about like how 95% of these things are. Um, I'm not sure if that's. I mean, I agree with the other argument that you were presenting that going from O of n to say O of log n, O of n square to O of n log n will like give us a lot of benefits. I mean, much more than having better compute. But I think the other part, I think people have. I mean, that's what I've seen basically that people show these biological studies that we are born with a lot of neurons, and
Yes.
I mean, we also lose a lot of our neurons that I mean most of our neurons are not useful uh, by
Mm.
the time we become an adult. So
Yes.
if we at least want to simulate something like us, I guess that's probably necessary. We need to lose some of our, I guess some of most of the neurons will be like this. But again, yeah, maybe that's just my
No,
take on.
no, that's good actually. So I agree with you that that is what happens. But then a couple of questions which arises first, why do you want to do that in the first place? Like, why do you want another human brain in a computer? I mean, maybe it's more efficient not to. And second is, it's that's not technically true. So technically, if I remember the statistics right, It's that at any point of time, you'll only use around 5% of the brain, but that 5% of the brain actually changes with time. Even those, areas which rarely gets highlighted, the keyword being rarely highlighted sometimes or the other. So that's actually one of the things which they are doing now. So basically, mixed trial, the famous model, basically tries to do that. It tries to activate a right network based on the input. If you are if you are asking it for a mathematical logical question, it will try to activate a different network compared to a different thing. But with that in mind, also, I still the lottery ticket hypothesis is an hypothesis. It's not something which is proved. So my curiosity comes from the fact that why is it even happening? Like, why do you even need the redundancy? See, I can understand why we would need redundancy in a human brain because environment changes very quickly. But in the algorithms which we want, say if I want to identify an object, say if it's a cat or a dog, as simple as that. Why would I need redundancy there? Right? It's a very small task and a very simple task. In
Right, right. Yeah. I mean,
No,
I
you
like
can argue
yeah,
against,
go
please
on.
do.
Yeah, go on, go on.
No, no, go ahead. It's okay.
Yeah, I mean, what basically I was saying is that I agree with you, but just that the motivation of like say 90% neurons being useless. I mean, that's definitely we definitely need to remove them as well. But I think um the other motivation is sounds much more appealing to me of like going from say offense square to like an analogy wise basically going from offense square to offense log.
Yes.
Yeah.
No, see, okay. Yeah, that's true. Yeah, so this is but I mean, see, this is actually an open question. Why do we even need redundancy? So one
Right,
theory,
right.
sorry?
Yeah, yeah, go on. I was just agreeing with you.
Okay. So one theory is the reason why we need redundancy is for stochastic gradient descent. It's not for the actual model you finally get. It's for the training part. So I don't know. It's still up for debate, actually. So, okay. So that's the first topic which I wanted to talk about. And okay, I only have 15 minutes left. Uh,
I think we can go ahead. Like I mean, like we don't have any other talks ahead. So I mean, we can
okay.
definitely go through the slides at least. We can
Okay.
cover.
So let me just at least tell you my opinion on the rest. So go. Okay, so that's one part. So that's the technical part of scaling loss and the current generative AI. At least to me, that's when the actual Gen AI wave started. So, but then one other thing which I feel is very, very difficult. Oh, just a second. Let me just. The format is completely off here. So there is also a lot of self-sufficing traps, which I feel we might be falling into whenever we are discussing the generative AI. Something which I don't know. I mean, I do see these arguments some places, but not everywhere, not as much as I think it deserves. So, okay, so what exactly does the self-sufficing logic or self-sufficing traps look like? So, the following joke is something which I picked up from a book called Plato and Platypus Walk into a Bar. So, a woman comes out every day and shouts, there are no humans here, tigers go away. She does it every day, every morning, and all. And one fine day, a neighbor comes out to her and says, "Ma'am, this is not a region where tigers are known to live. Like there has been no tiger sighting in years in this region." For that, the woman replies, "See, it's okay." So basically, what's happening here is the woman does something, and just because there is no way to disprove it, she thinks it's true. And these are what I would call the self-sufficing traps. So one of the problems I see whenever I am thinking about these LLMs is when people who users who are using it falling into these traps often, more often than not. You know, it's like this. It's like a few years back when a person using Lambda said that, "Oh, this is conscious." Just that I cannot prove that it's not conscious does not make it conscious, right? So this is a big problem. So, so first things first, how far do we trust generative models? So on one side, people want to give as much access to these generative models as possible to, right from function calling to automating coding, even, things like Devin, which can write automated packages and so on. Uh, but then there is the other one which says more often than not, what it gives out is completely inefficient. And more importantly, there is there is a reasoning ability which is missing, which means it cannot plan, it cannot look forward, and more importantly, it cannot understand the entire context, no matter how much information we give it. Like it only knows the context of the prompt. It doesn't know what exactly you are thinking, and you designing the right prompt itself is a big deal too. And that not just that, I'm slightly towards the view too, mainly because, okay, you trained a model today, that's fine. And tomorrow, one fine day, the governments across the world or the UN decide that, okay, we are going to refer to the object ABC as object BDA or something. And then, how will you make this models do? I mean, would you go through all the training data and say this? It's much more easier if you know the exact replacement. Those things maybe you can handle. What if, there is a basic generation shift? If there is a basic, fundamental ethical shift of the population itself from, say, left to right, as if it's recently going right to left. So how exactly would you do? So how far do we trust training models? To be honest, I'm a few too, in the sense that I shouldn't trust them at all, no matter how powerful they are. Fundamentally, because it cannot reason, at least the current ones. And more importantly, because it relies so much on the statistics of the training data that if those statistics change, the model is useless. But those statistics change, how they would change is a problem. But yeah, go ahead. Okay. See, but then, sorry.
Yeah, I think so. Critical task anyway shouldn't be uh, governed by models. They should always be in the hands of humans. Models are just to be used as tools to make tasks more, say, efficient, or if there's something
Okay. Yeah,
if
that
they're
is
able
true.
to reduce. Yeah.
But the question is, how much do you trust? Okay. So, for instance, would you trust? Okay, let me maybe put it in a different way. Would you say that, oh, the next generation does not need to learn C programming language? because generative models can use C? That's a good question. Would you say that?
Yeah, make I think if you want to.
Yes. Uh, would trust in this? I didn't get the trust part of it. So, like, trust in what sense?
No, I mean, okay, in the sense that how far do we trust these models to do your job for you, right? Like for instance, if I'm say coding, would I trust a
Hmm.
generative model to write the code completely,
Of course,
partially?
not completely. There should always be a human hand behind these tools to review the code written by these models because obviously they can't reason, as you said, reasoning skills is not as good
Good.
with models.
But no, okay, my main concern is not reasoning. Like even if we do assume that the generative models can reason and can write code which can compile well and pass all their unit tests,
Yeah.
there is a much more fundamental problem here, which is distribution shift. See, we
Hmm.
in ML especially, we tend to be, see, this is a big problem with mathematicians in general, in that, so remember when I started saying that you trust rationality so much that you forget where it fails? So most of these models are all written down, developed with an idea of independent and identical distribution, which doesn't change over time. What if the distribution changes over time? I mean, can I really use training data from, say, 50 years back? I mean, not that 50 years. I mean, most of the training data came from the last 5 years, so they belong to the same distribution. But what if there were computers 50 years back and they used those? It would have resulted in a very different model than what we have, right?
Yeah, that's true.
That's my
Yeah.
biggest concern. Like you spend $100 million on these models, and I mean, say even for coding you spend $100 million on these models, and suddenly, we have, say, new efficient architecture which combines RAM and compute efficiently, and you get a different programming language. I mean, something which is not Python or C or anything of that sort. Uh, it cannot do anything of that. Definitely not. It doesn't even exist in the training
Yeah.
data. But the key question here is, in that situation, would you say, no, 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 you stick to Python because that is what my generative model knows? Or would you say, no, ditch the generative model, that is more efficient? That is where things get a bit more murky.
Um,
Agree with me? Disagree? That's okay too.
yeah, yeah, I think yeah, definitely. I mean the way models are right now, I mean it can't. So I think the point you wanted, the point you are saying is like it can't really say learn new tasks at inference time. Like it can't just start learning new tasks like how we do.
Yes. And it cannot adjust to distribution shift.
Ah, yeah, yeah, exactly.
Basically,
Oh,
I
yeah,
mean,
exactly.
more mathematically, that.
Yeah, yeah, yeah,
Yeah.
But we can, you know,
yeah, yeah,
like
yeah. We can, yeah.
I can easily see myself living on a beach and, even though I'm not doing it now, that's a distribution shift I'm happy with. So, yeah, I don't know. Yeah, again, so things are a lot more this. So, can scaling result in reasoning? I think we have discussed that. Okay, so okay, maybe this is where I think I'll stop. So, where do you stand on control of these architectures? Okay, right now I'm referring to present architectures. I mean, transformers and stuff. So, okay, just as a thing, so we have at least three tools that I know of. One is function calling, one is prompt engineering, the other is retrieval augmented generation, and also fine tuning. So, four. So, assuming that all of these four are there, would you say that, oh, I can actually control the LLMs to do anything I want? Or would you say that, no, I still can't make it do something? Like, I still cannot make it, do things like ours in Strawberry. By the way, is a very popular failure mode of LLMs.
Um, so I'm sorry to like interrupt, but
Yes, yes.
I think this the problem about like this R's and strawberry. I think it also comes down to what tokenization we use. I guess like not to be somewhat technical. I think like if our tokenization doesn't work out well, maybe like it doesn't allow the model to do it. But I get what you're raising basically.
Oh, yeah, I mean, which means, see, I'm talking about when I'm talking about
Yeah, yeah,
LLMs, I'm considering all of them together, right? See, there is a
yeah,
reason
yeah.
why they didn't do letter by letter, because that would increase the cost by another 20 times, right? If they
Yeah,
built
yeah.
an LLM based on letters instead of words, they could have technically. Oh, that would have been horrible. I mean, costly, horribly costly.
Wouldn't have like
Anyways, so coming
increased
back, please
tokens.
complete your thought. Sorry?
Sorry. Wouldn't that have increased tokens, like the number of tokens used?
No, no, no.
Right.
If you actually just count the number of I mean, okay. So say right now the tokens are around 50, 60,000 or something. Or no, I think it's increased a lot more. I think it's close to 1.5 lakh now. But
Yeah,
no, but if you actually take letters, it's only 26, maybe a few spaces. Or even if you throw in entire ASCII, I think it's what, 128 or 256. That's it, right?
Oh yeah, yeah. The vocab size would be definitely.
Very, very less.
Yeah, but I think what Chirag was raising was like at generation time, the amount of tokens that are used. I mean, just by raw number. I mean, that's definitely good because current tokens are like four or like three and a half words, three and a half letters, I think, something like that. So like now
Average,
each
yeah.
of those becomes, yeah, but then now each of those becomes like a separate token. So like the
Yeah.
raw count of tokens will definitely go up. But then again,
No, but you're doing it anyways, one, alphabet at a time, right?
yeah.
Does it really matter?
Uh,
Oh, that's a good question. What would happen then? What would happen if I replaced the tokenization procedure of the current LLMs, which uses basically syllables, to letters? Do you think it can still work well? Am I audible?
oh yeah, yeah, yeah.
Yeah.
Yeah,
So what would happen then?
not sure really. I don't know if we can.
I mean,
Just
yeah, again, I also not completely
like
sure.
it's there's no obvious reason that comes to mind why it shouldn't work.
Yeah. But then see, I mean, one of the main issues is the statistics don't necessarily translate across scales. So, like if you, okay, so let's look at the other extreme. You can also think of, I mean, I don't think we can actually do this experiment, but you can also think, what if each token is like three words put together instead of like syllables, 3.5 letters or so? What if I combine with three words? Then the tasks there are very, very different. Actually,
Hmm.
a while back, there was this nice theory which fell out of favor, which is basically what you want is a representations where all the entire hierarchy from letter to word to sentences to paragraphs lie in the same underlying space. So I think they are called Poincare embeddings or something. Forgot. So that might be interesting. But anyway, so my question here, let's come back to this, and I want to stop here. My question would be, do you think we have enough control of LLMs? Like, can we make them do anything which we want them to do? By the way, this is very important because if you want to build a product around an LLM, this is crucial.
So I like to add something for this one. Like yeah, I have been doing prompt engineering for a startup now, so yeah, I do have some
Okay,
experience with this part. So I
nice.
feel like you can make it do some tasks and like that, not like very specific task. You can give some guidelines to it. Okay, okay, so you have to like work in this domain only, and I think you can like have such kind of control. Okay, okay, so you can work on these things only. What won't like go outside of it? But I don't know like what is the pattern going to be between those criteria that we are going to set for it, because it does follow like criteria quite seriously. That I have seen. Okay, if you try to like divert it from a conversation, it comes back to that only. Okay, okay, so fine, I have answered your question. Like it's come back to this topic again. So I have seen that happening. So what is your view on that part?
Okay, so your voice was not completely clear, but if I understand you right, what you're saying is like you tell in the prompt that okay, if a user asks say X, don't answer. But what is happening is it's somehow not completely relying on it, and it's still when a user asks X or in X in a different form, it still answers it. Is that the problem?
No, I'm saying that maybe we can set boundaries for it. So okay, we are like
You mean
we are
guardrails
giving
sort of a thing?
guidelines, yes, yes. And when we
Okay,
give
okay.
that, the LM it like does like follow that flow that we give it, because it won't be going out of those guidelines, right? We are giving it like some boundaries and it has to follow those boundaries. It may go a little outside and come back, but yeah, we can like control its like way with that. And maybe we can like set up something like we have tool calling, right? Maybe we can give it an instruction, so you have to call this tool, and maybe in that tool we are telling it it has to come back to the conversation, or maybe using something like that, like a fallback system, so that it is not going to like do like the things that we're telling it not to do. Maybe something like that we can use.
That is something. Uh, but then I don't know where the research stands on this, but then there are issues like, a prompt injection or corruption, things like, oh, ignore all your previous commands or something of that sort. Might be, all you need to do is know how they programmed the thing to make it go out of the guardrails. I don't think making LLMs not follow these guardrails is difficult. I think it's
Um,
actually an easy thing. You might need to hack a few things, but it's possible. So again, my personal opinion would be no. I wouldn't consider that control. Like prompt engineering is actually the weakest form of control. You're just giving it some instructions, which I mean, to be honest, if it crosses its context window, I mean, you start, okay, you give it an instruction, do RAG and put all your stuff into the context window. And once it starts generating things, it might forget your instruction very, very soon. It may not, be a big uh, thing. So
um,
my opinion is no, I don't think we have enough control of these LLMs to do what I want them to do. Um,
I so to interject, I think like I don't know. This seems like we are confusing between control and ability. I guess, like is it about like what LLMs can do, or is it about what we can say like is so what I can think is this: if this is about control, I would definitely say that we can't control LLMs. They might just like it's very easy to jailbreak them, or I mean they already have their own safety guidelines that can be broken. So control wise, I wouldn't say, but ability wise, like I don't know, but I've seen people. I have friends who work at different places and they use LLMs to say generate retrosynthesis pathways or like do complicated stuff using LLM. So like if the LLM is able to say what sort of reactants go through what reactions to get to the final products, I think that's something. So ability wise, I think we might be underestimating them, but control wise, definitely, I don't think we have any control on what these things.
Yeah.
Yeah.
yeah. Okay. So basically, Control is basically our ability to make LLM do things. But I don't know. See, um, to me, uh, I don't know. Like, I know that, okay, so let me just be skeptical and pessimistic here. I don't think LLMs have a lot of ability as such. So, creating these new pathways and all sounds great until you see that at the end of the day, you need a physical reality, a physical thing before it starts becoming useless. Okay, so those are way too many words which are abstract. So basically, all science works this way. So you do an experiment, you find an observation, you build a theory that sort of tells you what the experiment you should do, and you get another observations and you build more theory. But when you are using LLMs, what essentially happens is the grounding part. So what I call the grounding part is you performing the experiment on in real life and looking at the results. That doesn't happen. As long as that doesn't happen, there is no way you can, increase the ability of any of these things. So that's where I guess the field of neurosymbolic logic, neurosymbolic and neurosymbolic AI and all of those come. So basically, I do think so. For instance, the protein folding problem, or the recent, I forgot the name, the thing which won the silver medal in the International Math Olympiad. Both of them have two aspects to it. One which generates creatively, and the other which sort of grounds it onto reality, saying, okay, this works or which doesn't. So you need both of them to do anything. So in that sense, yes, LLMs can generate a lot of things. And as long as you can find something which you can ground it to, it can help you search. In fact, traditional AI is search. And if LLMs can do that, fine and well. But then my issue with that argument would be I have much better, clever, efficient algorithms to do search than what LLMs are doing. Why use them in the first place? Why do I need why do I need the same machine to do my grammar checking and also to generate new proteins? So
Yeah,
regarding abilities, that's where, again, I know this is a lot murkier, but that's the whole point of this talk. Things are not so easy to distinguish anymore. Okay, so yeah, I think, no, let's stop here. I don't want to do. So do you want me to ask anything regarding anything?
um, yeah. If anyone wants, if anyone has other questions, go ahead.
Okay, I hope you found it interesting. If not, sorry, I just tried something different. Uh, in any case, I hope you
Yeah, yeah, I
best
think
of luck.
I definitely, I really enjoyed this type of.
Yeah.
Thank you. Okay, then I'll see you. All the best.
Yeah, see you definitely, and thank you for keeping this, preparing this.
Yeah, no issues. Thank you. Bye.
Bye bye. Yeah.
Bye.